Okay, now I think I'm recording. Yes. All right, guys. Yeah. So, Wednesday last week, I introduced this notion of random variable, and we discussed probability distributions. So let me just remind you very quickly what do I mean by probability distribution. Okay, so X. Just to remind you. So probability distribution, again, it's just an assignment. So you assign a probability to each, let's say you have a discrete random variable. So you're gonna assign a probability to each value of your variable X. Okay, so probability distribution is an assignment of probability for each value of X, for each value of the discrete random variable X. Anyways, I think we had probably just one. I'm not sure how many examples we had, but there's one exercise left from last Wednesday, right? So can I just remind you of the exercise? So we had the following. So yeah, this exercise is about the number of committees in BCC. So we said we have like 100 committees in BCC, and the variable X, your variable X is going to be the number of professors in the committee. All right, so yeah, so we have this following results of the following survey. So I think X, the first row, that's your variable X, and then the second row, that's the number of committees. So for example, we have 20 committees with one professor, with exactly one professor in the committee. We have 25 committees, right, with 2 professors in the committee. We have 5 committees, I think, with 3 professors, exactly 3 professors, and 20 committees with exactly 4 professors. And finally, I think we have 30 committees with exactly 5 professors. All right, so again, the X, that's the number of the professors in the committee, and that's your discrete random variable. Anyway, so I think we had to find, we need to find like the probability distribution, and then we need to graph the probability distribution, and then there is some question about some probability, right? I think so. We need to find the probability distribution. And then we need to graph the probability distribution. And then there's a question about the probability. So what's the probability that committee Okay, of course, the committee is selected at randomly chosen, right? A committee randomly chosen, it has 3 or 4 professors, right? I think this is the exercise left from Wednesday. I don't think I don't think I solved number 1, right? I'm pretty sure I didn't solve anything. Let me check my notes. Did I solve? No, I
No,
don't
you,
think.
you
No, no,
didn't
I
solve
didn't.
anything.
Okay,
Yeah.
perfect, perfect.
It's
I'm sorry. I mean, yeah, I just,
okay.
I forget. Yeah, I just, I forget sometimes what I did last week. All right, so, um, yeah. So first, number 1, find the probability distribution. So we have the variable x, right? You have your variable x. So again, the values of x. So x can be 1, x can be 2, x can be 3, x can be 4, etc. Can be 5, right? That's like the possible values of x. So like here, x has exactly 5 possible values, right? And that's why actually x is a discrete random variable, right? So it has a finite number of values. Anyway, so x can be 1, 2 or 3 or 4 or 5, right? Now, for each x, what we're gonna do for each x, we're gonna assign the probability. So for each x, let me write it down here. So for each x, or for each value of x, let's say, for each value of x, value of x, we're gonna compute the probability of x. Okay, so for example, if x is 1, right? This is the first value of x, this first possible value of x. If x is 1, right, then we need to find the probability that x is equal to 1. Okay, now what does it mean, the probability that x is equal to 1? The probability, so this is the probability that x is equal to 1, but what's x? X is the number, remember x, we said it's, where is it, x here? We said x is the number of professors in the committee, right? So what we are looking for here is the probability that there is exactly one professor in the committee, right? Again, of course, we choose randomly the committee. We have 100 committees, right? So this is a probability that there is exactly one professor in the committee. Okay, so to compute such a probability, remember guys, the formula for the probability, it's the frequency of the event, the occurrence of the event, right? So how many times or how many committees with exactly one professors over the total size of the sample. We have in total 100 committees, right? So here in this example, probably that x is equal to 1. That will be the number. So this is like the number of committees with one professor with exactly one professor, right? Over, of course, the total size of the sample. So the sample here is the survey. In the survey, we have 100. In total, we have 100 committees, right? So the size of the sample is 100 because in total we have 100 committees, right? So we divide by 100. So then, yeah, so this probability of x equal to 1, number of committees with exactly one professor, that's this number right here, this 20. So 20, this is the number of committees with exactly one professor. Okay, so we have 20 committees out of 100 with exactly one professor. So that's 20 over 100, right? So this is 20 over 100, which is, of course, if you use your calculator, I mean, this is 1/5, which is 0.2, which is 0.20, and which is 20%. Okay. Any questions so far, guys? How I got this probability of X equal to 1? So that's the number of committees, one with exactly one professor over, of course, the total number of committees. And of course, we can do the same thing for like probability of X equal to 2. So probability of X equal to 2, that will be like the number of committees with 2 professors over, the total size of the sample, and that's 100 committees. So we have like, in this example, of course, we have 25 committees with exactly two professors. So that's 25 out of 100, right? So we have 25 out of 100 committees with exactly 2 professors. So that's 25 over 100. That's 1/4, so that's 0.25, and that's 25%, etc. So then at the end, we're gonna have, the probability distribution. So here's the answer. Probability distribution is so first you have the values of X. So X is 0. Not 0. So the values of X. So X can be equal 1, 2, 3, 4, or 5, right? So from 1 to 5. So here X is 1, X is 2. Probably need more space here. Sorry about that. 2, 3, 4, and then 5. And what I'm gonna do, so to each value of X, I'm gonna assign a probability, P of X. So when X is 1, for example, when X is 1, so we said the probability that X is 1 to have like exactly 1 professor in the committee is 20%, right? Or 0.2 or 0.20, right? So here we're gonna have 0.20 or 20%, up to you guys. When X is 2, probability that X is equal to 2, that's, we said there are 25 committees with exactly 2 professors. So that will be 25 out of the 100. And so that's 0.25, right? So here we have 0.25. We do the same for phi. Phi, we have 5 committees out of 100, right? So 5 over 100, that's 0. Of course, 0.05. Then next value, 4. So 4, we have 20 committees, right? Out of the 100, that's 20 over 100. So that's 1/5, which is 0.2, right? Or 0.20. So here, this is 0.20 or 2. And finally 5. So we have 30.
0.15.
Sorry?
0.15.
What is that? Oh, for the 30. Oh, yeah. Thank you. Oh, yeah. Oh, yeah. Thank you. Thank you. 0.30. You mean 0.30, right? Yeah. So this is that's what I call a probability distribution. So this is my probability distribution. So this table or this chart, this is my probability distribution. Any question, guys, about this probability distribution? So you see how we find the probability distribution? All right, excellent. Next, we need to graph this probability distribution, right? So we said Wednesday last week, we said we can use the histogram actually to graph this probability distribution. So for number 2, so we want to graph this probability distribution. So again, guys, the idea here, why we can use the histogram here to graph this probability distribution because, I mean, this values, this probability distribution, it's just the relative frequency, right? It's a frequency over the size of the sample. And that's exactly the relative frequency. So my histogram is going to display, instead of the frequency, my histogram is going to display the relative frequency. So yeah, anyway, so here we get the horizontal axis, we're going to have X. On the vertical axis, we're going to have P of X, the probability of X, right? And then on X, let's say, so this is 1, this is 2. So the values of X, possible values of X, 1, 2, 3, 4, and 5, right? And then possible values of probability of X. I mean, P of X, the smallest value is, as you can see, smallest value is 0.05, and the largest value is actually 0.30. So we can, so on this vertical axis, I'm gonna put 0.05, 0.1, 0.15, 20, 25, 0.30. Sorry. All right. So we're gonna graph first. We're gonna start with 1, right? That's the first value of X. So what I'm gonna do, I'm gonna draw like an interval with 1 in the middle of the interval. Let's say this, you see this blue interval? So as you can see, 1, this is because we have a discrete, we have a discrete variable. Like when we make the frequency table and then the histogram, in the frequency table, we had like classes. So we had like intervals, right? But here, because the variable X is discrete, it's not an interval, it's given just by one value. So that's why, so here, for example, so I'm gonna put 1 in the middle of my interval, and then I'm gonna draw like a rectangle with height. So 1, the probability of 1 is 0.20. So we're gonna go up to 0.20. And that will be my first rectangle. Okay. All right, next value, it's 2, right? And the probability of 2 is 0.25. So again, I'm gonna draw this interval with 2 in the middle of my interval, and we're gonna go up to 0.25. So this is my 0.25. Right. And then phi, it's 0.05. So we're gonna go up to for phi. So here's my interval, which represents the discrete variable X equal to 3. And then we're gonna go up to 0.05. So this is my like 0.05. Now 4, it's 0.20. So here's my interval. This yellow interval represents my discrete random variable X equal to 4. And we're gonna go up to 0.20. So up to here, I guess. So that's my rectangle. All right, and then last value 5, it's a 0.30. And so 0.30. So here's my 5. This interval here represents 5, and we're gonna go up to 0.30. All right, and yeah. So again, this one here, it's in the middle, my interval, etc. So this is a representation, or I mean, this is the graph of my probability distribution, right? So the graph actually is just the, it's the, if you take the sides of the rectangles here, this is actually the graph of my probability distribution. Okay. So again, so what we need to observe here, guys, is that the area, as I explained last time, the area under this graph is actually equal to 0.1. So just to remind you here, that's because the sum of the probabilities is 1, right? Because the sum of the probabilities is equal to 1, the area under the graph is equal to 1 unit square, of course. Okay. Any question about this graph of the probability distribution? Make sense to you guys? All right. So then I think the third question. Let's see, what's the third question? Where is it? Well, yeah. What's the probability that the committee has 3 or 4 professors? So for P, so we are looking for the probability that X is 3 or X is 4, right? And again, just remember, guys, so this is like P of A or B. A would be the X equal to 3, that's the event A. So this is like my A, and X equal to 4, that's like my B. All right, and remember, probability of A or B, that's probability of A plus probability of B minus probability of A and B. All right, so this probability of X equal to 3 or X equal to 4. So that will be probability of X. So let me just write it again here, or sorry. Or X equal to 4. So that's probability of A. So that's the probability of X equal to 3 plus probability of B, X equal to 4. Now, minus probability of A and B, which means that X is equal to 3 and X equal to 4, but X cannot be equal to 2 different values, right? I mean, either X is 3 or X is 4. It cannot be equal to both, right? That's not possible, right? So this thing here is not possible, right? This is just 0, A and B. This is just 0. So yeah, so it's just probability of X is 3. That's well, it's from my probability distribution. So as you can see from my probability distribution, probability of that X is 3 is 0.05, and probability that X is 4 is 0.20. So here the answer would be 0.05 plus 0.20. So that's 0.25, which is of course 25%. Okay. Let me see the chat if there's any question. All right, no questions. Yeah, so that's for the probability distribution. As Asanta said at the beginning of the lecture, there's like in the homework number 4, or number 4, yes, in the problem number 3, the third problem, right? So we need to find like the expected number of kids, and there's this standard deviation of probability distribution. So yeah, so today, so this is for the exercise left from last week. So today we're gonna discuss first today. So we're gonna discuss the mean and the standard deviation of a probability distribution. Okay. So first, let's start with the mean. So the idea here, guys, is that, so we have this probability distribution, and the idea is that each value of X, has P of X chance, or so each value of X, so each value of X has P of X chance to occur. Okay. Now the mean. So what's the definition in general? The mean, again, this is the mean. Well, it's supposed to be the average, of course, but the mean is actually, the expected number or the expected value of X. The mean. This is the expected value of X. Value of X. So for example, like in the previous problem with the committees, right? In this problem with the committees, your X, that's supposed to be the number of professors in the committee, right? So then the mean of this probability distribution would be the expected number of professors in a randomly chosen committee. So if you select randomly, if you select a committee, right, at random, then the mean, that will be the expected number of professors you're going to have in the committee, right? So again, you think of the mean, guys, as the expected value of X. Okay. Now, so as I said, each value of X has like P of X chance to occur, right? Because the P of X, that's the probability that X occur, right? Now, the thing is, this chance, this is like the weight. You think of this chance as the weight. I mean, if some value of X has more chance than another value, it means that the weight of this value of X is larger than the weight of the other value, right? So the mean here in a probability distribution actually corresponds to the weighted average. So in oops, sorry about that. So in a probability distribution, the mean corresponds to just to the weighted average. The mean is the weighted average. Okay. Now, what's the formula for the mean? This is exactly the same formula as for the weighted average. Remember, guys, we discussed the weighted average, when we computed the mean, different kind of means, right? So the weighted average was like, X times the weight of X. So here for the mean, it's the same thing. So the mean, so I'm gonna denote the mean of a population probability distribution by mu. All right, so this is called mu. So this is mu, mu. This is, of course, a Greek letter, mu. So this is equal to sum of X times the weight of X, and that will be the P of X. Okay, so this is like the weighted average, X times the weight of X. All right, so yeah, so for example, well, I'm gonna just use the same example as the exercise. So we have like, we have these 100 committees. And we got the following probability distribution, and we have so we have the following probability distribution. Distribution, which is, just to remind you, so this is so we have the X here, 1, 2, 3, 4, 5, and then P of X. So again, this is the X here, of course, this is the number of the professors in the committee, right? So here X, of course, this is the number of professors in randomly selected or randomly chosen committee, right? In a committee. So yeah, so we had, I think, 0. So for 1, we said, where is it? So we have 0.20, 25. So here we have like 0. This is 0.20, 0.25, and then we have 0.05. Right, and then I think here we have 0.20 and then 0.30, if I'm not mistaken. Yes. All right, so let's say you want to compute the expected number. So here's the question. Compute. That's not the question. Compute the expected number of professors in a committee, of course, selected at random. Right? Again, we have 100 committees, right? And so what I'm saying, guys, is that you pick one committee at random. What's the number of professors that you expect in the committee, right? All right, so then yeah, so then we said, so the mean, the expected number of professors here, that will be the mean, right? So whenever you see expected number, it means the mean, like in the test or in the final or wherever. So expected number, that's the mean. That's what we mean by expected number. So yeah, so that will be the mean, mu, and we said it's like x times p of x. Right, that's the formula for the mean, the weighted average. Anyway, so yeah, in this example, so the first value of x, of course, is 1, and the corresponding p of x is 0.20, right? So that'll be like 1 times 0.20 plus, because this capital sigma, guys, this is a capital sigma, it's a summation symbol. So we have a sum here, right? So x goes from 1 to 5, of course. So next value of x is 2 times, right here. This dot, it's of course it's multiplication here, right? This is multiplication. Anyway, so this is 2 times 0.25. That's the corresponding probability of x equal to 2. Next, plus 3, corresponding probability is 0.05. Next, x is 4, corresponding probability is 0.20. Plus x is 5, and corresponding probability is 0.3 or 0.30. All right, so don't forget, of course, your PEMDAS rule, guys. We multiply first. All right, so we need to multiply like this: 1 by 0.20, 2 times 0.25, you know, etc. So we multiply first. So that'll be 1 times 0.20, of course, that'll be just 0.20, plus 2 times 0.25, that's 0.5, plus 0.15, plus 0.80, plus 1.5, right? And the answer, let me see my notes. So the answer would be 3.15, I think. This is 3.15. Okay. So what's the interpretation again of this number? So you need to understand the interpretation of all these numbers, right? So 3.15 means that, so when you select a committee at random, we expect to have like 3.15 professors. I mean, of course, the 3.15, the 0.15 doesn't mean anything because you cannot like, you cannot like divide a professor into like decimals, right? But that's the idea. The idea is like approximately we have like 3 professors, let's say, in a committee. So the interpretation here, so we expect to have 3.15 professors, which is kind of close to 3. So approximately 3 professors in each committee. Okay, so that's the expected number. Any question, guys? So that's for the mean, right? It's just the weighted average. Now, now the standard deviation, right? Again, just to remind you guys, the standard deviation measures the spread of your data values. Okay, so here the standard deviation would measure the spread of your number of the number of professors, right? So the next, so we have the standard deviation. So number 2, the standard deviation. Okay. So just to remind you, so so the standard deviation measures the spread of your values above the mean. Above the mean. Anyway, so this probability distribution. So what we're gonna do, guys? So the standard deviation is gonna be given by. So the standard deviation. So standard deviation. So it's gonna be given by the. So what we're gonna do is. So when we have a population probability distribution, we're gonna denote the standard deviation by sigma. So the standard deviation is denoted by sigma. Denoted by sigma. Okay, so this is again sigma, lowercase sigma. And so then the sigma square. So there are like 2 steps to compute the standard deviation sigma. So first we need to compute the sigma square. So the sigma square would be equal to so the difference between, so it's going to be the sum. So it's going to be x, the value of x minus your mean square. Okay. So this is x minus mu. This is just a square. This is like the square of the distance between the mean and the value of x times, of course, the weight, which is given by the p of x. Okay. And then, of course, so this is like a kind of a weighted distance. The weight would be p of x minus mu square. You think of x minus mu square, that's the distance from the square of the distance between the mean and the value of x. And then, of course, sigma would be just the square root of sigma square. So as an example, guys, I'm gonna just use the same example. As I'm gonna use the previous example. So as example, Again, we're gonna have this 100 communities, etc. We computed actually the mean. So the mu, we said the mu, where is it? 3.15, right? The mean, the mu, this is the mu, the mean of my probability distribution is 3.15. So this is 3.15. Okay. All right. So so as a first step, I'm gonna compute sigma square. It's better to go step by step, guys, because it's easy to get confused. I know some of you had to trouble with the standard deviation of the test. But anyway, so yeah, so this is a sigma square. Let's start with a sigma square. So it's going to be equal to, so we said it's x minus mu squared times p of x. So what we're going to do, first we start with the first value of x. So the first value of x, of course, is 1 minus the mean, which is 3.15, and then square, times the probability that x is equal to 1, right? So probability that x is equal to 1 is 0.20, right? Right here. This is probability of x equal to 1, 0.20. So so times, so this is a multiplication here, times 0.20 plus, now again, because we have a summation here. All right, so next value of x is 2. So there'll be 2 minus 3.15 square times the probability that x is equal to 2. That's 0.25, right? 25. Next value of x is 3. So that will be 3 minus the mean, same. It's the mean doesn't change, right? The 3.15 is always the same. 3.15 times probability that x is equal to 3. I think it's 0.05. Right? And then x equal to 4. So again, minus 3.15, sorry, this is 0.15 squared times 0.20, and finally x is 5, minus 3.15 squared times 0.30, or 0.3 or 0.30. All right, so yeah, again, PEMDAS rule, guys, right? So PEMDAS rule, we need to do the parentheses first, right? So PEMDAS rule. So parentheses first, right? You do the subtraction inside the parentheses, and then you do the exponent, which is a square, and then you multiply. And then last step, you're gonna add all the values, right? So let's subtract first. So this is 1 minus 3.15. So that will be negative.
Negative 2 from
yeah, yeah, negative 2.15 square. Be careful, guys. Negative 2.15 square with this, with the square of any number is going to be positive or 0, of course. Okay, so the square of any number and any number is going to be positive, okay, or 0. So this negative 2.15 squared times 0.20 plus, I'm going to just do the details here in this example. All right, and then next time, I think, I mean, if you have like an exercise, I'm going to just give you the answer, but I'm going to do this in detail so you can see the how do we compute this, I mean, this standard deviation. Yeah, and then so negative 1.15 squared, right, and then negative, sorry, negative 0.15. Oops, come on. Yeah, negative 0.15 square times the 0.05 plus, so 0.85 square times 0.20, right? And then 1.85 squared times 0.30. Right. Next thing, guys, is of course is the square. Okay, so as I said, the square of a negative number is going to be positive, right? I mean, your standard deviation must be positive anyway. So if you have like a negative number as answer, of course, there's a mistake somewhere. So yeah, this negative 2.15 square would be equal to actually 4. Let's say 6.2. Okay. Times 0.20. It's positive, of course, positive 4.62 plus, and then this negative 1.15 square, of course, that'll be equal to positive 1.32, let's say, times 0.25, etc. So this is 0.15 square. That'll be equal to 0.02 times 0.05 plus this is 0.85 square, so that'll be equal to 0.72, I think. My notes are correct. 0.20, and finally there's this 1.85, so plus 1.85, of course, squared, that'll be equal to 3.42, I think, times 0.3. All right. And then next, guys, once you're done with the square, as I said, square of any number would be positive or 0. Then next, of course, you multiply. So you multiply like before, this 4.62 by 0.20. 1.32 by 0.25, etc. And then you take the sum. All right. So again, guys, my advice for you, because this is, it's easy to make mistakes here. So my advice, of course, if you want to end up with the right answer, go step by step. Anyway, so yeah, you multiply, this 4.62 by the 0.20, so this is equal to actually 0.924, right, plus etc. right. I have the answers here. I can just probably give you the answer. So this is 0.25, so this is equal to 0.33 plus this is 0.01, right? 0.02 times 0.05. So this will be equal to 0.001, right? And then 0.72 times, the 0.2, that'll be equal to, of course, 0.1, let's say 44 or 4. Anyway, and then finally 3.42 times 0.3, that'll be equal to 1.02, I think, or 26. Right? And then this is the last step, of course. And then now you can, add all these numbers. I guess I need to mute someone. Sorry. Yes. Yeah. So, so here the answer would be, of course, let me see my notes. This is the standard, this square of the, right? This is the square of the standard deviation. So that will be equal to, yes. So that's equal to 2.425. All right. So this is, again, this is sigma square. And then the standard deviation sigma. So they'll be equal to 2 point, let me see, yes. Sorry, 1 point, this is square of, so this is square root of 2.425 and that will be equal to 1.55 or 56. All right, so this is your standard deviation, right? Again, it measures the spread of your data values about the means. In other words, it measures like, you know, the difference, like the average distance or the average difference between your mean and the value of x. Any question, guys? So how much time do we have? Like we have 20 minutes. We can do one exercise, or we can move to the next section, but next section, of course, 20 minutes, it's not enough. So what I'm gonna do an exercise. All right, so let's do an exercise. And then next time, even if we don't, even if I don't go over this exercise today, I guess the next time I'm gonna just, I mean, on Wednesday, I'm gonna just start a new section. Anyway, yeah, and remind you again, guys. So Wednesday we're gonna meet in person, right? They fixed the heating problem, so now we are back to the campus. Yeah. So here's an exercise. So so if we don't finish the exercise today, you can just think about it at home, of course. So this is exercise. So I'm gonna take an exercise from the textbook. So we have this x. So let's say x, this is the number of fish. Let me see my notes. So here x is, let's say, the number of fish caught in, let's say, in 1 hour, or a 1 hour period. Okay, and p of x. This is a percentage of fishermen who catch x fish. For example, x is equal to 1. So the p of x equal to 1, that will be the percentage of fishermen who catch like 1 fish in 1 hour period. While, for example, fishing in a lake. Right? Anyway, so we have the following probability distribution. So so here, first row, of course, that will be the values of x. So that's the number of fish caught in a 1 hour period. So let's say x can be 0. 0 fish caught in 1 hour period, or 1. We have also 2, 3, and then 4. Now p of x. So this is a percentage of fishermen who catch, for example, when x is 0, that will be a percentage of fishermen who catch 0 fish in 1 hour period, right? So 0, we have 0.44. 1, we have 0.36. 2, that's 0.15. 3, that's 0.04. And 4, that's 0.01. So here, guys, the probability distribution is given, right? You don't have to find the probability distribution. I mean, like in the homework. So if you check the homework, let me see the homework. So in the exercise number 3, so we have the survey 100 couples, etc. So first you need to find the probability distribution, right? So this is like the problem with the committees in BCC, right? We had to find the probability distribution first, etc., etc. So here in this exercise, the probability distribution it's given, right? It's this table here. As you can see, this is your probability distribution because you have P of X here, right? That's your probability distribution. Anyway, so what we can do here, so because we have already the probability distribution, nevertheless, we can first try to graph the probability distribution. To so what's the probability that a fisherman let's say catch at least two fish, right, in 1 hour period. Right. 3. What's the expected number? The expected number of fish caught by a fisherman. By fishermen, of course. Right, and then for what's the standard deviation of this probability distribution. This distribution. All right, guys. So let's see how much time you have. Well, it's not bad. I mean, we have like 15 minutes. So in the so let's say you have 5-10 minutes to think about this exercise, and then hopefully I'm gonna have some time to solve the problem. So I guess with this exercise, I mean, you can do the exercise number 3 in the homework. So you have everything you need to do the homework number 4. So please don't forget your homework number 4 due this Wednesday. So after this, guys, we can move to the next section, which is the section 6.2, which is binomial distribution. I think binomial distribution, this is like the most important, one of the important distributions. Yeah, I guess next time I'm gonna start a new section, the binomial distribution. Let me just say, guys, here from number 2, when I say at least, is here at least 2 fish, it means 2 fish or more. Okay. At least 2 fish, that's 2 fish or more than 2 fish. Um, okay, guys, I mean, we have like just 5 minutes, so I'm gonna probably give you at least the answers, so we can, try to see if you can check if you can get the right answer. So, well, let me discuss number 2. So for number 1, the graph, I mean, this is, well, I hope you know how to graph this probability distribution. Again, it's just, the histogram. This is exactly what we had like in the previous examples. Now, for number 2, so what's the probability that the fishermen catch at least 2 fish, right? So as I said, 2 fish, at least 2 fish means 2 fish or more than 2 fish. So it's either 2 fish, right, or 3 or 4. Okay, that's at least 2 fish, right? It's 2 fish or more than 2 fish. So it's 2 or 3 or 4 for number 2. So then, yeah, so to answer number 2, so that will be probability of, so at least x is equal to 2. So that will be probability that x is 2 or more than 2. So that will be, or x is 3 or x is 4. All right, so that will be equal to, again, we're supposed to use, probability of A or B. So that's probability of A plus probability of B minus probability of A intersected A and B, right? And I mean, as I explained, A and B, probability of A and B here would be just 0 because X cannot be equal to 2 different values, right? So x cannot be equal to 2 and x equal to 3, right? So it cannot be equal to 2 different values. X can be equal to just 1 value, right? So probability of A and B is just 0. So here it's just probability of x equal to 2 plus probability that x is 3 plus probability of x is equal to 4. Okay. Again, here I'm supposed to use the addition rule. Here I'm supposed to use the addition rule, as I explained in the previous example. And yeah, so probability of x is equal to 2. That's just from the distribution table or probability distribution. So it's 0.15 plus 0.04 plus 0.01, right? So it's 0.15 plus 0.04, yes, yep. And then 0.01. So then the answer is 0.20, and that will be 20%. All right, what's the expected number of fish caught by fishermen in 1 hour period, right? So that's, again, expected number. That's the mean, right? So whenever you see expected number, that's the mean. So we are talking about the mean here. So for number 3, we need to find the mean, the average of x. So the mean here, which is a mu. So I said it's x times p of x, right? So this is, so first value of x, of course, is 0. So that'll be 0 times probability of x equal to 0 is 0.44 plus 1, probability that x is 1 is 0.36. Then x is 2. The probability that x is 2 is equal to 0.15. plus x is 3 times 0.04, and x is 4 times 0.01, and the answer, it's 0.82. Supposed to be 0.82. Okay. And again, the interpretation here, so this number means, so we expect.
So Professor, just to confirm what you said.
Yeah.
So whenever in a question they say at least, we know that it means or. We have to know it's or, right? Just like how you said that when you say expected numbers, they're talking about the mean. So when they say at least, they're talking about or. That's the formula we're gonna use, addition.
Well, at least means that's like the minimum.
Okay.
When I say at least x is equal to 2, it means that the minimum for the value of x is 2. So then the minimum is 2. So then it would be 2 or 3 or 4. I mean, at least it doesn't really mean or, but it means that's like the minimum for the value of x. But then, of course, when you say minimum is 2, so then, well, then that's like saying it's 2 or 3 or 4, right?
Yes.
And then, or then, and then, okay. And then you use this addition rule, of course. So then an interpretation, I mean, that's a good point, all right? But again, at least means that's like the minimum number, number. Yeah. The interpretation, of course, here we mean that we have we expect to have, so we expect that a fisherman catches like 0.82 fish. Well, that's not a lot. I mean, it's approximately 1 fish in 1 hour period, of course. And then for number 4, I'm gonna just give you the answer, guys, because time is already over. For the standard deviation sigma, the answer should be, and again, my advice for you guys, because I know some of you had trouble with the standard deviation in the, in the test, in the first test. So again, my advice, try to get this answer, which is 0. So sigma for this problem should be 0.899, right? So check if you can get this 0.899, all right? All right, guys, I'm gonna stop here. Thank you for listening. So I'm gonna see you in person on Wednesday, and next time we're gonna just move to the next section. Thank you, everyone, and
good night.
Good night.
Thank
you.
Thank you. Bye.
Bye.
Professor, did you take the attendance?
Excuse